Hey, it's James from Finney Electrical. I've got Ellis from Finney Electrical, and on today's video, this is the Apprentice does fault finding. Let's get into this. Right, we're into the job now then. So, this is this crunch of the grass. Nice, satisfying. Right then, so this is Apprentice does fault finding. Co-starred by Ellis, the Apprentice. So he's getting a few bits out then. So he's got a big flat, little small flat, little posi. And he's got his tester and he's ready to go then. So, where are we starting, Ellis? You don't know, right? So I missed a customer. I'm gonna walk you through what the customer told me, because obviously you don't even know what's going on, do you? You're just doing this job and he doesn't know. So first thing you do is what's not working. So in the garage we've got a couple of a cable coming out, and basically there's all the lights all the way around here, yeah? Or what he said. He said that it's tripping the RCBO, so there's some sort of RCD fault, yeah. So it could be a short circuit or it could be earth leakage, yeah. So the cable comes out, we can see it disappears there, and if we walk down here then, there's a light hidden in a bush, which was on its ass a bit, so I'll show you. We're going under. Oh, yeah, there it is. Right. Oh yeah. There we go. Right, it's got a light here, yeah, on its belly. Yeah. It's falling off the wall, and it's got, looks like all these brambles have killed it, but this, you see that, it's an armoured cable there, it goes into a box here, so there might be that to look at. That then pees around. Oh yeah. Through here. It'll come up into this building somewhere. Don't see where it comes up, but it'll probably come up under the ground and pops up, but there's that light which will be on it. You can see a little armoured cable there, so there's that to look at. And then there's a light on here, in that bush. And then we'll take you around this way. Oh, little robin. We've got this light here, yeah, so it comes up there. And then it peels off around the garden, around there. So, where should we start then, Ellis? That sounds good. Right then, so inside then. So, Ellis decided to start on the inside, which is fine. So we've got this old fuse board set up. They've had this little thing device put in. Now, we've got lights here, which when you turn it on trips out, and it's been disconnected. When you turn on the one that says folly, it turns on now apparently, but if you plug it in, it's been tripping out. So what we need to do is look on the outgoing side of these. I think in fact some other electricians have been and done some bits, so they might have disconnected it. But we'll open this box up and see what's going on. But that's all I know, so now it's over to you. There's nothing on the bottom of that, so that's why it turned on. There's nothing actually in at the bottom. Yeah. So that's that. There's a random neutral of that. Alright, so that's not doing anything, yeah. That's not even connected in. So it looks like they've just extended the line through here and the neutral, and that's how they've done it. So we found the circuit that's been disconnected then. So this is the cable that goes out. Apparently they've used one of the lines for the folly to make the sockets work and used the same neutral as the return, and they've used the red one as the lights. So what we've done, we're just testing now. So we've got line to earth, and it's just pressed test, and we're getting 0.18. So we should get that from line to earth. So there's an issue, like a dead short. So if we did 230 divided by that, that'd be a very high current, wouldn't it? So obviously we've got an issue there, and then it's just doing neutral to earth as well. We're getting 23 ohm. Obviously that's through the resistance of the bulb, probably, or the light. So what do you think we should do? Do you think we should check that first light? Because 0.18 is quite low, isn't it? Yeah. So you'd think it'd be this quite close rather than all the way around there, wouldn't you? So should we go look at that fallen member? Freezing. Oh. See my breath. So I'm getting spiked now. Can we see it?
Brambles have literally grown into it.
I know, the brambles are grown and pulled it off the wall, haven't they? Can't get around this tree.
Get this off.
Oh, so get to the front of it and you'll take it off fully. That's it, have a good wrestle. Yeah, so we should have some screws somewhere, like a normal light. Right, so something underneath. We'll get that off, it should flap off, and then there should be 2 screws holding onto the back box, shouldn't there? Yeah, don't lose it, just in case wants to keep it. There we go. Yeah, look at him.
Sure. Be it.
You'd think, wouldn't you?
Yeah,
Very wet, isn't it? Right, so you see them 2 screws there, should get that off and get him disconnected. What we can do, in fact I'm not saying that because you need to figure this out. Don't round it off. You have to get the drill out. Yeah, let's see, we've seen a frozen snail.
What?
Look at him, he's attached to a branch but he's frozen to it.
There's one in there?
Oh,
it's done that.
There we go, we'll get him off. We'll get him off. Right, this muddy mess. There's loads of soil in there. So yeah. Right, shall we maybe chop that and wiggle it and then test it. Chop, strip it, test it. See if it clears up board, yeah? Oh, we've got a little rabbit. Hello. Hello. Hello, little robin. This is freezing. It is cold, to be fair. Mr. Robin's still there. So we've got a little friend for now. Oh, I'm giving me his one with these. Plus I can take business calls whilst working. Brilliant these. Sony MHX5s. Absolute brilliant. They work as ear defenders as well. Because they're noise cancelling. Absolute genius. So he's got these strips. And then he's going to do some testing to see what's good and what's bad. There we go, 10 mega ohm. Keep going and we'll tell you the verdict. What's the verdict?
Blue's bad.
Right, so
Yellow's bad.
we've got blue and yellow bad on this side, which goes back to the fuse board. It could be that just touching something back there, but we'll check out. And then what have we got? Black and red or what?
Black and red.
Black and red are these, going back to the fuse board.
Fine, aren't they?
They're fine, yeah, same to earth and to each other, and then all these are good, apart from that blue one going out, so we'll see what's going on with that, right? So the fuse board, can't remember what the colours do. Right then, let's see what the colours are doing. So we've got red and black. I know there's loads of copper hanging out, but still. So red and black were clear, weren't they?
Yeah.
So they go to here, so they're not connected to out. So the cable itself is clear, yeah? You happy with that?
Yeah.
And then we've got yellow, not a good one, it?
Yeah.
And the blue were bad, but the blue were bad, i.e. earth to neutral, but obviously earth to neutral, if it's a TNCS or whatever, earth is neutral, so that's why we're getting a reading between neutral and earth. It's because it's connected to neutral. So right then, so what we're going to do then is go into the rest of that circuit then and see what does what then. So in fact it was just a blue core which was bad, wasn't it, on that?
Yeah.
Sure, there might be a neutral to earth fault if they've kept the colours as blue as neutral. Yeah. But what we can do is power up the red and the black and get them on a neutral, get them powered up, connect that through and then see what comes on. If not, we'll have to take apart every single light across this full place and then do checks. And we don't want to do that, we just want to power it up and see if it trips. but by the test, it shouldn't trip. So they should power up and we could see what works and what doesn't. That's going to be a lot quicker, isn't it? Right, how we do it? Colour to colour, yeah? Let's turn it on. Here we have a child in need. Please give today. It looks so pitiful. Oh lad. Right, is it really happy to have a brew? Oh, that'll warm you up from inside. So, we've just proved, Ellis has just, well, told me what to do. You don't work live, but right, so we've got red and black, which goes to red and black there, which goes out. We turned it on, it hasn't tripped, and there's obviously power there, look. So I think that just does the power in the folly in this little building here. So we'll check this power there and we'll check if the lights are live or dead. But I'm pretty sure the yellow is the cable that makes all the lights turn on. We'll have to refeed that fully anyway. What we could do is in that junction box, the red and black come in, and we could just connect them to the yellow and blue going out, and all the lights will work and the folly will be disconnected. Yes, in the folly we go. If you want to get your socket tester. and plug in. We'll see if that is the case. If that is the case, well, you can't have, basically, I'm not talking to you through a mirror, but you can't have one cable with multiple feeds in it, because if you turn the power off and you think it's dead, it's fed from other breakers, and it's not that good, is it? So, a bit dangerous. So really it needs its own feeder, yeah. Turns out, yeah, that socket wasn't live, so in testing you've got to make assumptions and then just go do it and see if you're right, but we're wrong in this case, aren't we? So, let's go to that junction box we're starting the bush and see if there's any power there. Right then, so we just powered this up. So obviously it goes through an RCBO, so if there's any earth leakage, greater than 30 milliamps it'll trip. And we've powered that up, so we've just banged both live together and both neutrals together and see what's going on. So these lights should be on now. We'll see what's working, what isn't, and then we'll go from there. Oh, we've got to turn the breaker on on the other one, yeah. So basically, what the old electrician's done, they've got the old board powering up an RCBO which goes out. So yeah, it's tripping out. It's tripping out. So there's an issue between there's still an issue between yellow, which is one of the lines, and blue, which is the neutral. So we're now going to look into the circuit further. So unfortunately, it would have been a lot quicker just to get that powered up and then walk around, see what lights work, what doesn't, and go from there. But yeah. Right, so with the circuit disconnected, we'll test neutral to earth. Give him a press. What have we got? Greater than 2000. We'll insulation resistance it. So what we're doing is testing the little range. We were testing the 0 to thousands. Now we're testing the millions. There we go. Perfect reading. Greater than 100. So that's great. Because we're on 100 volts. Let's do this line. So that's the red. I'll press it. We'll just go straight in for insulation resistance. Greater than 100. Back down to continuity. And we are testing this blue one to earth, and we're getting 358 ohms, so there's something going on there. And then we'll go line to earth, and we're getting greater than 2000. Step up to insulation resistance, testing that higher range. So now sending, and we're getting 0.01. So obviously when it powers up, it's just going through the resistance of the light and causing an issue to earth. So neutral to earth on part of the circuit is bad. So how do we fault find that then, Ellis? If you've got a big, so it starts here at the fuse board, it goes all the way around his property, all the way around. What can we do? What do you think? We don't want to take it apart every light and check. But what we could do is what? So you've got a big circle. Do you think we could chop it in half and test one half and other, like we do with other fault findings, yeah? That's what we'll do. We'll find a light that's easy to find, that's in the middle somewhere, and we'll see if it's bad going all the way back to here, or we'll see if it's bad going that way, and we'll be a lot easier to figure out what's what. So then, we've got all this garden, we've got a little pedestal here and all the way around, so I think best bet goes all the way down there. So maybe there's lights on this gate, so maybe if we go to that this end gate one, which will be easy to get to, disconnect the split them. So we've got blue and yellow, so we'll split them. So we've got one side going back to the fuse board, one side going around this way, and see which is good and bad. If it's bad round here, then we've got somewhere, and then it's just splitting again in middle, splitting again in middle until we find the bad one. Feeling hot. So we've got an old light that's just randomly on, probably off the other circuit, but oh, it's lovely and toasty. I'm going to stand here and do this light whilst Ellis can freeze over there. There's Robin's back. Where is he? He's here. Oh, he's there. Hello, little Robin. Nice over there. Right, whip the lid off then. Oh, I wish you could have seen this. We just got attacked by like 50 woodlice. They all come spewing out. Look at this. Those are wriggly as hell. Look at them all move.
What about me? What about me?
Ellis is like that. Absolutely disgusting. Look. This could be a issue, to be fair. This box could be just full of woodlice. Look at them all wiggle away. Right, we're hoping for the same experience of like 50,000 woodlice flying out. Oh, it's not that bad, this. We had loads though. Absolute tons fly out. Right, now all them little mini beasts are gone. Oh, just crawling around, little dirty things. Right, so we just tested these. 0.51 we got. That's with the cable coming in, and then the cable going out then. Should we test that then? It's insulation resistance. 0.01, right, so the issue is coming out, so we can technically power that up and then everything past this, everything coming in will be right, 0.00, so the issue is actually further down there. So all that, all the way back is good. Next, so what do?
Split it now.
Split it again. Talk about pick your poison. I've gone with this. This is the easier one. So a load of lantern lights, I don't have to mess about. Oh, I'll go with this. So, what a junction box. Let's open this lad up, see what's going on. There being buddy. What have we found then? We've got a junction box here, that's buried. Where the lid's gone? Fired under there somewhere. It's over here. So a junction box, you're supposed to get some magic gel, it's called. It seals it all off. That's just a load of water at the bottom of here, look. So let's disconnect that and see what we can get going, really. We'll just use like a white cable. It's got no impact rating at all, that. It's not armoured, is it? Right, let's even see if it's on that, because it looks newer cabling. So what we've done is gone non-RCD line, took the neutral, and powered up all the lights. Now, if that's not even live at that junction box, then it's on a different circuit, and we don't need to worry about it. So, what are you cheering at? Of course it turns on. There's a neutral to earth fault. We need to look at. So obviously it works all here. I see a cable disappear. I thought it went there, but it doesn't. It actually goes to this. There's an armour that goes into the back of this light, and then what they've done is gone, oh, we want some spike lights, and then someone's run some flex round and into that junction box that's wet. So we will disconnect those and see if that clears everything. Sure, we'll do the disconnection at that junction box where it was all wet. Right, the wet box then, so neutral to earth, 0.03. So the dodgy electrician who's gone white flex cable in, it's good, but the cable going out is not good, and they haven't even earthed the armoured railing, so that's not good either. Great. Right then, so this will pee off round here and probably feed the lights that go down there. So we'll have a look down there next. Made me laugh at that. Look at this. Bag anyone? Oh, not even a proper box. It's a metal box. Dug under the ground with a plastic bag through it on it.
Put bubble wrap on it.
Bubble wrap. Parcel Force, bringing electrics to you. This could be the issue then. So this junction box is dodgy, but it's all crispy, as if it's been arcing. And literally I went to strip it and the chipped it and the whole cable flew out of its thing. So we took it out of the box. This could be the issue, so we're going to strip this and test it. We could be onto a winner. Here we go. Right then, so that light is showing clear, and we're getting like greater than, we're not getting like 0 point something ohms on the continuity. So that we might have found it. So let's go fly a kite. Now let's go to the last joint where the incoming comes in, because we disconnected it, you see. If that's clear there, then we're kind of good to go. Hang on a minute, well, we've got some funny biscuit business going on. Biscuits, instead. Right, so I think the electrician, the stupid electrician that wired it in white flex, has also done neutral to earth reverse. So normally electricians will wire, it might be controversial this, but they use black as the earth and grey as the neutral. But at that junction box, neutral was earth. Sorry, the grey was earth and the black was neutral. That's right, yeah. But when we've just tested it out, we're getting some funny readings between live and what we thought was earth. But obviously it was just live and neutral because the reverse polarity is wrong. So what we're going to do now then is just one delay just to check. So we're going to get core to core, end to end, and go beep beep, right, that's a tone of a low resistance. So that cable is that cable is that, and that cable is that. Then that way the polarity is right. Because they also said like when they took the earth out, they were getting shocks, and that would explain that. If you turn camera died so quickly, they were getting shocks. So obviously if with the neutral out or whatever, the return path going down the earth, and there's Ellis getting warmed by the light. Back on. There we go, so we've just proven that line is line. Right, I want you to do neutral next, so the blue one. So we think it's going to be the grey one. But there we go then. Stay there. So they'd wired the grey one as earth, and that's why we got reverse polarity. Right, let's see how we do then. So earth to neutral. We'll test at the lower range, and I'll turn everything off. Right, so greater than 2000. That's insulation resistance. It. No, what's going on? 0.06. Let's do this then. Continuity on this, and then 0.05. So still a fault somewhere. So back to the drawing board. So we're nearly there then. So what we're gonna do then? I'm gonna the dodgy connection. What we're gonna do is go back to that and split it there, and then see if it's clear here. If it's clear there, then we can turn it on and make sure everything's working, and then we're just gonna fault find the rest of that circuit. Hey, so we did some digging about, and these are all back on now, which is great. So it was that dodgy light which was giving some bad readings, but yeah, we're back on. So just gonna have a little tour around the garden there. Yeah, all these lights are on, and these are working on the RCPO, which is great. Yeah, it's all working, so that's great. All these lights are on, so what we need to do is go in the orange now. So once these sockets working, now that we're going to wire into the photocell, so everything kicks in via the photocell and it pings on, which is great. But his orangey sockets are only going to work when the photocell's on, which is obviously not what he's not going to want. So, but for now, just for a temporary fix, we'll have to get another cable over here, so these can be powered up. But we can power up the red and black, so it's on the same circuit. They'll come on, and his Christmas tree lights will work, and he'll be happy with that, I think. So I think we'll go with that. So these sockets aren't live at the moment, so see what's going on. But we've got red coming in though, and black going there. So look at Ellis' socket. We did who's disconnected this? So I'm guessing. Alright. Yeah, one of them will be live, mate, that's just popped out. So, yeah, you are right, it is a bit silly. Right. Let's just get the death stick. Yeah, it is live there. Right, should we turn power off and we'll get this connected in? Obviously, you don't use this for checking dead to work on it, you just use it to see if it lights up. Right, let's get that connected in, those sockets will come live. We'll plug the little Christmas tree in, and these lights here will come on. Happy days. That's wired in now, Ellis is going to bang that back on. We should be getting power! But only power. So you're going to wire the photocell. It'll only come live when the photocell comes live, which is not right great. At least his fairy lights will work for Christmas and he'll be happy. So, happy customer. And then we'll have to quote just to get a cable really to the back side of that. Well, I'll have to get a cable after here. But yeah, this plugs in. And then reset. Everything lights come on that tree.
Oh yeah. No.
Twinkly twinkly light. He's gonna love that. Let's have a look. So we've got these lights here, yeah.
Oh well,
Yeah, so we've got these twinkly twinkly lights here, and then we've got some lights over there. I don't think you can see them on camera. So there we go, we're just testing it out now, but we'll just put the lid back on. We're gonna have a return visit then once well, I'm going to have a return visit to gel them up, get the magic gel in that, make sure it's all sealed in so it can get buried. And what we're doing now is just getting a jumper, putting it over the photocell and watching all the lights turn on, ensuring that it works when it gets dark. There we go, that's the photocell covered up then, and the lights have turned on. So we've got a little light over there, just to check. Should have, here we go, lights are turning over there. Jobs are good, and there's fairy lights are on, so it'll be lovely and happy. There we go, that's the board cover back on, so everything's RC protected, so when the gardeners are working away they're not going to get electrocuted or whatever. But yeah, what do you think, Ellis?
hard one.
Hard one, it was a bit of an hard one. So yeah, it's mainly because it's so much cabling and so much stuff to look at, but we got there in the end, the customer's happy, nice one. Here we go, this is the final challenge of the Apprentice then, so obviously they got sorted, they're happy from this morning. We've got to come back, but what we've got is some fault finding to do on this house, so let's go get it. Right, let's switch into the job then. So this is what's going on then. So we've got a little circuit here then, which does downstairs, which is this one. It does this utility and the kitchen lights. So that's what we're playing with. This is flashing away from the sensor. So what he's saying is it flashes and then, maybe it's, nope, still flashing. Anyway, it flashes and it trips out. So what we're gonna do, it hasn't tripped out. It's not tripping. So what we're going to do is get that pinged off, and then what do you think, Ellis? What can we do? What do we normally do for testing?
Insulation resistance.
Yeah, so start low, continuity, then insulation resistance. Do we pull line and neutral out?
Yep.
Yeah, so we'll pull line and neutral out, and then go line to earth, neutral to earth, and see if there's a dodgy going on. Yeah, it's off. Right then. See what's going on then. So we've got 2 cables in here, so we need to do 2 tests on 2 different cables in here.
Okay.
Right, just going to test them now. Right, so continuity then, earth to line and earth to neutral is greater than 2000, so back on insulation resistance then, and then we can check if we've got a dodgy going on then within the cabling. 0.13, so we've got something funny going on there. And 0.12, check the other one then. So earth to line of the other one, 0.37, and same way for neutral. Right, so we'll have to look into that then. Right then, so just done some testing then. So there's a 3-core on earth and there's a twin on earth. The twin on earth seems to do all the lights downstairs in the kitchen. The 3-core on earth, don't know what it does. Right, so what we've done then, we're just going to split that out. So we get 0.1, well no, it went 0.08. But on the lights that only go to the downstairs, we're getting 0. Well, it just keeps climbing, 0.55 mega ohm. So that's way better. Obviously it's still low, but you'd expect that if they've had like any damp issues or flooding issues. So what we're going to do is just put these on separate breakers then, so if it does trip again, at least it'll the 3-core, we'll know if it's 3-core or the downstairs lights, which is the issue. That could go to some random outside light that's just water in it or something like that, so yeah, we'll put that on a different circuit. Yeah, that was an easy one then. So everything tested out alright, there was nothing to look at. There was some slightly lower readings, but they're on that other cable which we moved over because there were two in one. And there's nothing to look at really, were there? So all we can do is just split it. If it trips again on the second one in, then it's the light. There's an issue with the lights, and as soon as it trips, we need to be out and so we can test it and see what's going on. That's intermittent fault. If the other one trips, you just got to leave it off and notice if anything's not working, and that's it really. So well done, Ellis. The Apprentice does fault finding. Right, if you enjoy this kind of content, hit the like button, hit subscribe, hit the little bell notification for know when we next upload. As always, I'm going from me and Stretching Ellis, and I'll see you on the next one.